In this section, you'll write and graph horizontal lines, vertical lines, slanted lines. Vertical lines are a special case because they are not functions. Here on the right, you see a line that has 3 points marked on it: 7, 0, 7, -5, 7, -10. However, the x coordinate does not change. The equation of this line is x equals 7. Next, let's look at a horizontal line. Here, if you look at this line, this horizontal line, y is equal to -12, and regardless of the y coordinate is always -12. So over here we have 5, 6, 7, 8. This is 8, -12, and this point here, so y is always -12. We can also write this equation as f of x is equal to mx plus b, and since the slope is 0, you get f of x equals 0x plus b. B is the y-intercept, if you recall, and if you look at the graph, the y-intercept is -12, so f of x equals -12. Just a quick reminder, slope is rise over run. In this case, the rise is 0, the run is infinite. This is how you write infinite. So 0 divided by infinity is 0. Writing equations of lines that pass through a point and are parallel or perpendicular to the line with a given equation. So here the given equation is f of x equals -5. And the point that we want the line parallel to f of x equals -5. So this is f of x equals -5. The line parallel to that goes through the point 7, 4 is going to be this one here with this coordinate. So let's see. This is going to be, I'm going to call it another function, g of x equals 4. The line perpendicular to f of x equals -5 goes through the x coordinate. So the x coordinate here is 7. So this is the perpendicular line with the equation x equals 7. Note that we do not use the function form because this is not a function. It would also be useful if we mark the point 7, 4, which is over here. P is 7, 4. This is the point P. Now we want to write the equation of a line that goes through the point 6, 0 and is parallel or perpendicular to the line that I have highlighted in green. First thing we want to do is rewrite the equation in slope-intercept form, which means you bring y on one side, bring everything else on the other side, and the resulting equation that we get is f of x is equal to 1/3 x plus 4. And you'll see to the right, that's kind of highlighted in a magenta or pink. This is the given line. So let me go ahead and highlight the given line. I'll highlight that in green so we can tell. This is the given line. The slope of the given line is m equals 1/3. So a parallel line has the same slope, and the perpendicular line has a negative reciprocal slope. We use the point slope form, and the given point is 6, 0. So we write y minus 0 equals 1/3 x minus 6 over here. That simplifies to this, and I wrote it in function notation, g3rd. And that looks pretty parallel to me to the given green line. Once again, the perpendicular line. What I do with that is I use the point slope form again and use the other negative reciprocal slope, so I get this perpendicular line. So the basic thing to remember is from the given line, all you are interested in is the slope. Let me highlight that here. This yellow is the slope of the given line. You don't care about the y-intercept or anything, just the slope of the given line. The third given line is x equals 9. Let me see if I can identify that here. I certainly can. It's this line over here. X equals 9. You see, if I look at this coordinate, this is 9, 0. So x is equal to 9 is the vertical line. And we want lines that are parallel to a vertical line. So that line that's parallel to this vertical line has to pass through the point 2, 4. So what we're going to have is this line here, and its equation is x equals 2. The perpendicular line is this one here, y equals 4, y equals -4 rather, and I'm going to go ahead and label that y equals -4. This can be written in function form, so I can also write it as f of x equals -4 if I want. All vertical lines are parallel. Okay, switching gears, graphing the equation. So given an equation, how do we graph it? First of all, you look at the form that the equation is given in. Here you see that this is given in standard form. Just as a reminder, standard form is ax plus by equals c. So the best way to graph an equation like that is to find the x and y intercepts. And here we go. The y-intercept is 0, -8. That's already highlighted. And this is -2, 0. In fact, I'm going to color coordinate that. Well, that didn't color coordinate too well, did it? Let's use the eraser and then go ahead and try again. Okay, that's much better. 0, -8 and 0, -8. So if you're given a standard form, find the x and y intercepts. Sometimes if you get lots of fractions and stuff, you may need to go ahead and find other points, any 2 points on the line, and go ahead and plot the graph that way. Okay, let's look at the next equation. We want to graph this equation. First thing you want to do is look at the equation. This is in point slope form, not quite the way we're used to, but we will rewrite it that way. So reminding myself, point slope form is y minus y1 equals mx minus x1. Okay, so first thing I'm going to do is switch the equation around. Now, so this is not quite what I'm used to. I would prefer to have the y positive. So what I'm going to do is I'm going to multiply this by a -1. Actually, that's not what I want to multiply by -1. It's the equation before that I want to multiply by a -1. So it's this equation. If I multiply by the -1 and I simplify it, my resulting equation y equals -2x plus 1. So this point 1, 0 gives me the y-intercept, and the slope is -2/1. If you say come down 2/1, so that's slope with equation y equals -2x plus 1. Sometimes you may be asked to solve by graphing, in which case you'll be given 2 equations. So let's look at the 3 different situations. If the lines are parallel, which means the slopes are equal, the y-intercepts are different, but the slopes are equal, there is no solution because the lines never intersect. Let's just go ahead and show that these lines go on forever. Okay, next situation. If the lines intersect, then there is one solution. So here we have 2 lines, f of x and g of x, and they intersect at this point here. And if I were to read the solution approximately, I would say it is about 3.1 and 2.2. That's my, that's my guess. The last scenario is if you have 2 separate lines. Let me repeat that. If you have 2 separate lines, but they have the exact same equation. So there's this one and there's this one. Okay, so the first line I would sketch is the yellow one. Then I would sketch the turquoise one on top, and you see that they are superimposed on each other. And since lines go on forever, f of x and g of x intersect at every point on that line, and a line contains an infinite number of points.